Yeah, it is still starting. Wait. Just...
Good afternoon to everyone present here. Welcome to the 6th lecture of the Chemical Engineering lecture series, which is being conducted by the Department of Chemical Engineering, School of Chemical and Biotechnology at Sastra University. As you may know, these lectures are part of your curriculum or extra curriculum in order to just gain some knowledge. Before we proceed, and I welcome our guest today, Professor Pradeep Kumar Mishra from the Department of Chemical Engineering at IIT BHU. I would request Professor M. Sarvan to give a welcome address, and then Professor Rangabhasham to introduce our speaker before we start to hear about the thoughts and words of our distinguished speaker today, Pradeep Kumar Mishra. Before I start, I would request all participants to mute their speakers. Any questions that you may have, you may post it on the chat box of the Google Meet, or you can actually give it to us at the end of the lecture. Professor Saravanan.
Thank you, Dr. Gautam. Respected and beloved Dean, Dr. K.S. Rajan, School of Chemical and Biotechnology. Respected and beloved Associate Dean, Dr. V. Panuswamy, School of Chemical and Biotechnology. Distinguished speaker for today's lecture, Professor Pradeep Kumar Mishra, Chemical Engineering Department, Indian Institute of Technology, BHU, Varanasi. My faculty colleagues and student participants. Good evening all. It gives me immense pleasure in welcoming you all for this for today's talk under this Chemical Engineering lecture series. Chemical Engineering Department at this institute was started in 1994, previously known as Shanmuga College of Engineering. Under the aegis of Shanmuga Chemical Engineering Association schema, students were regularly conducting symposiums and workshops, and later on, students started conducting conferences, national level conferences as part of the association activity. From 2011, where we had the formation of student chapter of Indian Institute of Chemical Engineers, we broadened the spectrum of your activities, student activities. As this current semester is predominantly online interaction we are only having with the students, and due to this lack of co-curricular activities which are previously undertaken by the students, is not possible now. And also they are missing the interactions normally they will have between the students and the industry and academic experts. So for that purpose only, we have created this forum of Chemical Engineering lecture series, where we are every fortnight we are connecting starting on September 5th. And every fortnight we had discussions related to various topics coming into the chemical engineering field from academia as well as industrial experts. So today's lecture is actually the last lecture under this chemical engineering lecture series. So as we are approaching the fag end of this semester, I hope today's speaker, Dr. Pradeep Kumar Mishra, and his topic related to chemical engineering in service of mankind will enlighten the current batch of students. And I also thank Dr. Professor Mishra for kindly accepting our invitation to be part of this lecture series. Once again, thank Professor Pradeep Kumar Mishra for being with us today. And I also welcome you all once again for today's session. Over to Dr. Rangabhasham.
Good afternoon to one and all. Our today's speaker, Professor Pradeep Kumar Mishra, working as the professor in the Department of Chemical Engineering in IIT Varanasi. He is the former head of the Department of Chemical Engineering. He obtained his bachelor's degree in chemical engineering from IIT Roorkee, master's from IIT Bombay, and PhD from IIT Varanasi. After his industrial experience, he has joined teaching at IIT BHU in the year 1997. With his academic and R&D contributions, he has placed to HAG scale in the year 2016. He has published more than 100 research papers and filed 5 patents, and obtained various research grants from various funding agencies. And he is actively contributing in the area of bioenergy and wastewater treatment. And with his expertise in the area of wastewater treatment and effluent treatment process, has been appointed as a chairman in the Committee of Formulation of Disposal Standards to Textile Industries. He also engaged along with his team members in UP PCB, JSPCB. He has contributions of innovation, incubation, BHU, Varanasi now. Received various awards and honors. A few of them are Doctor Partnership at Ministry of Environment, Forest, Climate Change. Dr. Sri Gandhia Memorial Sustainability Award in the year 2017, and various prize and nominations he have received, and also numerous training programs, summer schools in the area of energy, environment, and entrepreneurship and business development. Professor Mishra and his group is also working for the preservation for the culture of Varanasi through digitalization as a web and organizing workshops. So we are so honored of having you, Professor, in our university. So now I kindly request you to take over the session. Professor.
Okay, thank you very much for kind introduction. So today I'm going to present you on the topic chemical engineers in the service of humankind, and I will discuss everything right from what exactly the chemical engineering, how it is doing at present, what is the problem the chemical engineering has created for the mankind, how we are going to solve. I hope I am audible to you all.
Yes, sir.
Yes, yes.
Okay. So, and my presentation is visible to you guys.
Yes, sir. It
Okay.
is visible.
So I will take around 1 hour to complete the presentation, I suppose.
Yeah.
So I'll start.
Yes, please. Yes, please.
Okay, sir. Thank you. So I'll be starting remembering Pandit Madan Mohan Malvi at the Bharat Ratna, who was the founder of Banaras Hindu University, and he has even founded our own chemical engineering department in 1921. So we are working for the development of chemical engineering education in India from 21 till date, and maybe beyond one more century, I suppose. So India is not a country of Hindus only. It is a country of the Muslims, the Christians, and the Parsis too. The country can gain strength and develop itself only when the people of different communities in India live in mutual goodwill and harmony. So it is, I am echoing the word of Mahamana, that it is my earnest hope and prayer that this center of life and light, which is coming into existence, will produce students who will not only be intellectually equal to the best of their fellow students in the other parts of the world, but will also live in a noble life, love their country, and be loyal to the supreme ruler. So this is the underlining fact that in addition to being a good chemical engineer, we should certainly improve upon our personality so that we can add this word to make a beautiful place to live. One more quotation of Malviya ji, long back in 1909, more than 111 years. So in Lahore Congress, Malviya ji has told that if millions of people in this country are to be rescued from poverty, if new avenues for employment are to be opened and prosperity spread over the land, it is essential that an extensive system of technical and industrial education should be introduced in the country. The example of other countries point out that to be road to prosperity. So long back, even 120 years back or 110 years back, our forefathers has imagined that India can progress as compared to other developed countries only when we'll be improving ourselves in industrial scenario. So what exactly the advantage of India in current scenario? That is the point of discussion today. So India is among top 10 destination in biotech. India is having second highest US Food and Drug Administration approved lab after USA. We do have second largest manufacturing capacity in textile. With growing food demand, fertilizers and pesticide industry has to grow. Demand for clean water energy will increase every day. Third largest producer of chemical in Asia, and we are sixth in the world in terms of output, accounting for 2.11% of national GDP. The scale is tilted in favor of India due to the proximity to Middle East countries, which are the largest producer of petrochemical feedstocks. So these are the advantages India is having upon which chemical engineers can build their career. So I am discussing one, oil and gas. If you see, the demand for primary energy in India is to increase threefold by 2035. It is being compared between 2012 to 2035. It says that 16 million tons of oil equivalent from 3 million tons in 2013. So threefold has been assumed that energy requirement will be there in India. So policies such as the new oil exploration, licensing policy, and coal-based methane policy have been made to encourage industrial value chain, and already 34 blocks were put up for bidding. Several industries are increasing consumption of natural gas in operation. So if you see any sector, right from oil and gas or coal, you see that people are searching for cleaner energy. And whenever we are searching for clean energy, role of chemical engineers are very important into that. So this is the general, this slide discusses general about the engineering. So the person well equipped with the mathematical sciences, physical sciences, and chemical sciences, under the influence of political, social, and economic factors, when he performs for the betterment of his own country, his own society, that he is known as engineer, and the process is known as engineering. What exactly the chemical engineering? If you try to understand, it says that application of basic sciences, mathematics, chemistry, physics, and biology. Earlier, people were not considering biology as a part of engineering. But what we have seen that we chemical engineers, making base of chemistry, have created many refractory products, which have created immense pollution or immense degradation in the lithosphere, biosphere. So now scientists have seriously started thinking, cannot we mimic, nature who has created everything, and we can think of, following the principle of life sciences, including that principles in chemical engineering to make benign product, not biodegradable products. So in addition to basic sciences such as mathematics, chemistry, physics, and biology, we use engineering principles for the development of design, operation, and maintenance of processes to convert raw material to useful the human environment. That is the underlying phenomena. We have always should think that we have also to improve the environment. So it again says chemical engineers carry out their activities through a specific combination of physical processes, that is known as unit operation, and chemical process, which are known as unit processes. So people say that chemical engineering is a combination of unit operation and unit processes, thereby converting their ideas into the product, and which that particular product should be having viable commercial use and commercial value. And everything has to be produced in an economical way. That is the chemical engineering. So why chemical engineering is needed? Because it relies on the philosophies and biochemical, chemical, and they manage the resources, they protect the environment, they control the health and safety procedures, and while developing the processes that make the product we desire or depend upon. So chemical engineering is a very vast field, and earlier it was mostly dependent on chemistry, but slowly we are walking free of chemical. Not only we are not attaching only to chemistry, but we are moving towards geology, botany, kind of biotechnology, and all other life sciences stream. So what knowledge a student acquire while going through the chemical engineering? If you see carefully, we do study laws of conservation of mass and energy. We study flow of fluids, heat and material. We do understand reaction between materials, whether it is aided or unaided, to create newer product. We do develop different kind of materials, right from plastic to smart material. We go for separation of product, byproduct, to remove the unwanted material. And every chemical engineer must be aware that 60 to 70% of capital investment in industry is only for separation equipment. Why it is so? Because only pure products are having prices. To get purer products, we go for downstream processing, and that is known as separation process. We create energy resources, we do conversion of energy, and we do care for environmental pollution and control. In addition to that, we also study extensively in instrumentation and process control. So these are the basic knowledge chemical engineers are equipped with. So the chemical engineering is universal engineering, because the breadth of scientific and technical knowledge inherent in this profession has caused someone to describe this particular engineering as a universal engineer. And this is ideally suited to the student who are having good abilities in mathematics and chemistry. But now I will not exactly accept this statement, because now we are moving towards biotechnology, biology also. So the domain of this particular knowledge, that is life sciences, which was earlier not related to chemical engineering, is very much relevant in today's scenario. So we engineers do create or change the raw materials into useful products, and it is being used in every day in a safe and cost-effective ways. For example, petrol, plastic, and synthetic fibers such as polyester and nylon all come from one natural resource, resources or raw material, that is oil, which has been taken out from the ground somewhere. Similarly, we do understand and we can alter the chemical and biochemical or physical state of substance to create everything from face cream to fuel. So the synthetic base of these both the things are similar. Either you make a fuel or you make a face cream. That depends upon the processes we select, the raw material we select, which is being added to the original raw material to create the product. So what exactly is the chemical engineering? Scientists do experimentation in the laboratory, in the test tubes, to create the product. And when that particular product created by the help of unit processes are done in a large capacity with the help of unit processes, unit operation, that is the real word, and that is the chemical engineering. So right from long-lasting lipstick for cosmetic industry, to the drug, to the cleaner rivers, to faster bone repair medicine, delicious foods, and cleaner air, all is the chemical engineering domain. And we keep on doing this kind of services every day. And one very good example is aspirin, where chemical, when meets engineering, creates marbles. And even today, this aspirin, one of the first drugs to come into common use, is still the mostly widely used in the world. And approximately 3 crore 50 lakh kgs are produced and consumed annually, enough to make over 100 billion standard aspirin tablets every year. And even today, people are thinking of using this aspirin for in COVID-19 situation. So you see what chemical engineer had done for this humankind. So what are the opportunities for chemical engineering? I'll be going very fast, maybe sometime, because I'm going to cover a vast range of knowledge in one lecture today. So chemical engineering opportunities are biotechnology, biopharmaceuticals, food and drinks, water, biomedical aids, pharmaceuticals, cosmetics, bulk chemical, specialty chemicals. We do consultancy for design and operation. We are creator of energy resources, health, safety, environmental services, materials like semiconductors, smart materials. We create consumer goods. We work for education and even for business and finances. So these are the area where a potential chemical engineer can work depending upon his own ability. And that's why I generally urge upon the students that please try to understand yourself. What exactly is your positive attributes? What is your negative attributes? What exactly the knowledge you are having? What is your interest? Which particular subject is your interest? Decide upon within 4 years and 3 years, and then chart your path to the success. So what are the top 10 chemical engineering contribution to the society till date? I'm not talking about the future, but I'm talking about the past and present. And you see, first one, the creation of fuel. The world's economy needs energy to keep it moving. And chemical engineers turn fossil fuels into various energy supplies, such as gasoline, diesel, jet oil, etc. So this is one of the finest contribution of chemical engineering to the humankind. Second, in creation of cleaner energy. Now we are creating a lot of new kinds of battery, nickel metal hydride. We are doing lithium-ion batteries. We are also working on other batteries like nickel cadmium batteries. So these batteries, which can be charged n number of times. We charge it more, it will last more. That kind of innovation engineers are doing. So chemical engineers are creating a new generation of clean energy technologies, nuclear power plant, NIMH battery, alternative energy such as air, wind, water, solar, biodiesel, biogas, etc. We do create n number of products for growing populations. Like we do water purification. We have been taught that this earth is a blue planet. But what is the reality? We do have very less potable water with us. So we are using seawater, and the seawater can only be utilized when we will be using membrane technology like electrodialysis, reverse osmosis to get desalinated water for potable use. And Surat is a very great example of that particular technology. If anybody has visited Surat 20 years back, you would have not been getting good water to drink. But the Reliance Industries has created, revolution through their water desalination plant, and we are having enough, potable water there. We have added, this GMO foods. We created many green products, removing harmful sulfur from fuels, right from desulfurization of, crude oil to the desulfurization of biogas. We have developed technology, not only chemical based, but we are also doing on this bacteria based. Sustained nutrient replacement is being done. A very simple explanation is being done here, how the biogas is entering into a reactor, which is having filter bed containing the sulfur oxidizing microorganism, and how we are getting H2S free biogas. So this is the application of life sciences into the domain of chemical engineering, thereby reducing the dependence on the chemicals or refractory chemicals. We are creating better living through chemistry. We have made plastics, we have made smart materials, and you see day by day, even in automobile industry or aviation industry, the plastic parts are taking prominence. Similarly, we are sketching natural resources, stretching natural resources. So chemical engineers make innovative materials like synthetic rubber, bioplastics, and Kevlar. That is, bulletproof materials, only through playing with the molecular chain. So natural materials are latex tapped from rubber tree. It goes to natural rubber industry, and we make a number of natural products. Similarly, with the use of petroleum crude and natural gas, petroleum, naphtha out of petroleum, through petrochemical plant, we create monomers like butadiene, styrene, isoprene, ethylene, and then propylene, etc. That it is converted to synthetic rubber industry, and we create many products. Large scale production engineering is also a domain of chemical engineers. Scientists do experiments, which I have already studied, discussed earlier. And one example is 1929, Sir Alexander Fleming, who has discovered a strain of mold that inhibit the growth of bacteria, and this was known as the first generation antibiotic, that is penicillin. But we chemical engineers has helped this particular medicine to be produced in a bulk, to be supplied to the general masses. So whenever production of any novel material or anything is considered, on the forefront remains the chemical engineers. So other 2-3 examples are convenient and abundant food, healing diseases and extending life. Chemical engineers have created a number of medicinal formulas, and they also are powering the personal computers through germanium-based silicon chips that help our laptop perform faster, and from thin film liquid crystal to the software that stimulates complex industrial processes. So that is the extended domain of chemical engineering. If I talk about the job opportunities for chemical engineers, this is the general distribution. 22% goes to chemical industry, 20% to fuel or energy, 4% to electronics, food consumer, material, and so on and so forth. So you can see that there are wider opportunities for chemical engineers, and the students who can understand where they will fit, and they will prepare themselves according to that, the need of that particular industry, will succeed ultimately. So how to be a successful chemical engineer? It requires teamwork, innovation, vision, leadership, inspiration, motivation. These 6 are key component of success for any chemical engineer. So what is emerging chemical engineering? By 2025, world population will be over 8 billion people. That's a lot. Increasing the population means increasing the need, increasing the energy demand, and per capita energy demand will also increase with the development. Because if you see, the countries which are developing are still using lot small energy as compared to the developed nations. The majority of this growth will be driven by the developing world, where rapid improvements in living standards are evident, thanks significantly to the application of chemical engineering. Chemical engineering is at the center of a new industrial revolution, where economic wealth goes hand in hand with environmental and social sustainability. So whenever we are considering economic wealth of any country, we have to think about the environmental and social sustainability. That's why there are the newer challenges for chemical engineers, and that I will discuss after some time. So, and fast we are reaching critical tipping points, beyond which it will be too late to reverse negative trend. What is negative trend? Means deterioration of environment is very fast. So time has come. We should stop our activities which are degrading the environment. We think what exactly the knowledges we want, which can evolve ourselves in a better way to create a better situation. You just see this figure. It is taken by Boston Analytical Research. Global population 650 years ago, around 670 years, you can say, 1350, there are only 300 million people in whole of the world. And you see, majority resides near India, Southeast, and somewhat in Europe. By 1900, the figure has changed a lot. Now the population is 1.6 billion people. And again, you can see these dots. One single dot represents 1 million people. So you see China, Southeast, India, and Europe having majority of population even up to 1900. US was having small population even by 1900. But what is 2020? You just see 8 billion people nearly. And you can see how much populated the earth is now. So you can see within this last 600 years, population is exploded. Means you have to supply many things. You have to take care of the earth. Otherwise, that will not survive the onslaught of modern development. So that is two-sided sword. So global warming is lethal. Cause and effect of global warming is known to everybody. What is the causes and what is the effect? Causes is emission of greenhouse gases. And this is primarily from the energy production and energy use, 57%. And energy is very critical thing for the human race. Still energy uses will keep on increasing. So you have to create the less polluting energy sources. And other industrial activities are creating 3%. change in land use 9%, agriculture practices 14%, chlorofluorocarbons mostly from air conditioned, freeze, etc. are creating 17%. And what is the effect? Sea level is rising, ozone layer is reducing, increased intensity and frequency of extreme weather events, impact on agriculture and spread of diseases. So this is the dynamics of deforestation ecology, and it requires the repurposing of our chemical engineering knowledge. We are creating development through creation of newer material, newer product. We should certainly try to understand this particular dynamics of deforestation ecology. How deforestation is impacting the hydrosphere, geosphere, biosphere, and atmosphere. You can see increase in flood, aquatic habitat degradation, flow of water changes, lacks oxygen in waterways, soil erosion, loss of vegetation. So a number of bad impact we are doing on the earth. So this gives you opportunity to go for search of novel methodology in chemical engineering. So powerful forces at work, whether it is class of perspectives. We do have finite resources, but ecology is changing very fast. 65 billion tons of CO2 is being emitted. It creates a rise in temperature. It creates increase. It affects the sea level. Population is increasing. We have to ensure the equity. We have to minimize the deforestation. So how sustainability and development can go hand in hand is the new thought or vision for chemical engineers. So you see what exactly the current situation. This is 2004, only 16 years back. Again, Boston Analytical Research has given this, that the most of the world is still in the early stage of economic development. And we have created so much pollution. You see India, Indonesia, China are at the very bottom near the zero. 80% of the global population is still using very small amount of energy, less than 60,000 kilowatt hour per capita. Suppose the condition arises when everybody is using, as the energy is being used in Canada, US and Japan, what will be the situation? So we have to make balance, but still you cannot stop the usage of energy if you want to do the development of the world. So we have to create cleaner energy. That is one of the greatest challenge to a chemical engineer. So what is the new path will be, whether it is time to choose. You just see, if I'm talking about only plastic consumption per capita in selected countries versus GDP per capita, the data is of 2003, again 17 years old. You see that Singapore, Germany, US, Japan, they are using much plastic product as compared to India, again at the bottom. And India at this situation is creating a lot of plastic waste. You see our rivers are being choked, sewers are being choked. Everywhere people are, even burning the plastic, degrading the environment. So what will be the solution? Whether we can go on polymer-based plastic or we should go for biopolymers. That is the question to the chemical engineer. So what should be the holistic approach? There are problems, but there are opportunities. So what we should do, that we should make this interaction of these three things: energy, ecology, and equity. Ecology means we need sustainable economic development. Equity means we need energy and food and health for everybody, for every citizen of the world, and we have to create renewable and clean energy sources. So that is the need of hour, and we can expand the field. The chemical industry future will be dependent upon two strategic vectors. And what is these two vectors? And we have to create our perspective or balance depending upon that, between consumption and conservation, between point solution to the holistic solution. We have to balance between these two vectors, very important: balance of economic advantage and balance of ecology. Whether we are interested only in the economic advance or we are interested also in the ecology. So we have to choose between these two, or we have to make a balance between these two, and then we can decide about what kind of product we need. We should certainly need agro-based chemical industry product. We need system approach to energy transportation management. We have to do the recycling of the waste. we should certainly move towards carbon-free energy system. So this is the future vision for chemical engineers. And what is the strategic direction for chemical industry? We have to again balance ecology and balance our economic progress from negative to positive. So you have to create new games, energy materials. You have to create energy efficient consumption pattern. So we have to invest in next generation knowledge intensive solution. And what is that? That is small is beautiful. That is why people are talking about now, new material, nanotechnology, different kind of things. So there is a unique opportunity for chemical engineers, because chemical industry's knowledge asset is extraordinary knowledge base, which is rooted in the early stage of industrial revolution. We do consider transport phenomena as our backbone, because it gives us knowledge regarding to flow mechanism. We do understand size reduction because it gives us knowledge of surface properties. Kinetics, how fast we can create a reaction. What is thermodynamics, how far we can go. So these are the critical assets of chemical engineering, which other engineers don't have. So we should look for mega possibilities, the intersection of conventional engineering with the new technology. This is the future of chemical engineering. So the chemical fundamentals such as thermodynamics, kinetics, transport sciences, and the conventional unit operations such as separation, reactor, and heat and mass transfer system should be, taken together with the influx of new methodologies like genomics, proteomics, microfluidics, nanotechnologies, and new convergence technologies such as large database tools, predictive models, increased interactive. So there should be combination of chemical engineering, life sciences, and AI, ML, different kind of computational tools. So these new technologies could indeed trigger a new era. What will be process industry reconfiguration? We should take help from nanotechnology and optotechnology, biotechnology, information technology in upstream as well as in downstream processes. So newer horizons of knowledges are coming together with chemical engineering to create smart material and smart processes. And if you see the progress, productivity of society versus time, that is development of a more sustainable economic model. The first industrial revolution 1 was based on steam engine. Industrial revolution 2 was based on internal combustion engine. This is the information revolution. This is the information revolution stage. But still, we are moving to a asymptotic value. So the new thing will be agro-cell-based economy. Then only we'll move towards improved new socio-economic structure with a new agro-based revolution. There should be symbiosis of multiple disciplines: genomics, biosciences, unit operation, biocatalyst, convergence of technologies like convergence, collaborative, computer management and call center kind of thing. Means again, life sciences, chemical engineering, and computational engineering or information sciences. This should be the backbone of development, newer development or sustainable economy. So this is one example of agro complex. Resources, industry, critical issues, cereal crops, fruits, tea, vegetable, aqua products. Industry will be food and beverage industry. And what will be the critical issue to be solved? Increase in yield, quality and consistency, distribution system, downstream value addition and branding, cotton, silk, jute, that is fiber and fabric and fashion technology, how cost effective we can make, whether we can make consistent quality, whether we are aware of the fashion trends, do we understand the new application and development, then biomass, wind farming, seed oils, starches for energy, specialty chemical industry, all from biomass like herbs, medicinal plant, algae, azolla, vegetable oil, flowers. We can create pharmaceuticals and Ayurvedics, perfume, personal care. Resources are vegetable, flower, algae, natural rubber, starch, lignin, alcohol, starches. We can create dyes and pigments, polymer, epoxy glues, solvent and chemicals. All are now oil based, and we should certainly move towards biomass based. Similarly, furniture, paper, oil and lubricant. So there are n number of opportunity if you are moving towards agro complex, and that is, I suppose, is the future of chemical engineering, where agriculture, life sciences, chemical engineering, and again information sciences come together to build a sustainable world. So development and fine-tuning of biofuel technology could open up new vistas. We do have feedstocks. We can convert it with various processes like gasification, pyrolysis, anaerobic digestion, fermentation, microbial digestion, extraction, and we can create products like hydrogen, methanol, bio-oil, biogas, ethanol, biodiesel, and end uses will be fuel cell in vehicle, gasoline, diesel vehicle, or maybe generation of electricity. So this biomass energy development will require a full range of conventional chemical technologies, and we do understand, and majority of colleges have already started investing their time and energy into the different technology development in bioenergy. So biomass combustion, gasification, carbonization, densification, biogas production. The biomass densification, you see a very simple example to replace the coal. If all the waste land of the country can be utilized for the farming of high calorific value crops, they can be densified into the briquettes and they can replace the coal. Similarly, there are n number of opportunities in biomass taken as raw material and converting to the product and energy. So we can integrate power energy through large-scale engineering system where bioenergy, wind farm, PV array, all things taken together with even the help of fuel cell, other engines can taken together, and we can think of virtual power plant. So there are n number of opportunity, an opportunity in search of creativity. Nano manufacturing will need committed work. And who will do that? There are n number of challenges in nano manufacturing. And it calls for deep understanding of molecular behavior, which is required for accurate positioning and attack of molecules. So knowledge in quantum chemistry is essential. So chemical engineers who are interested to move into the nanotechnology, so certainly understand what exactly the quantum chemistry. And then they can scale up the process to convert the product in a cost-effective method. Safe memory alloys, that is the newer materials that can recover from strain when they are heated above a certain temperature. And the MAs have two phases, the high temperature phase, austenites, and other is martensite. One is hard, inelastic, another is soft, elastic, and complex structure. And this material has the ability to transformation between these two phases at different temperature, and it leads to safe memory. So the examples are this one: copper, zinc, aluminum alloy. So you see, chemical engineering is moving leap and bound in the newer direction to create newer material. We have the tools. We need the commitment to link supply and demand. Chemical engineering is having all the tools. And what is the supply-demand dynamics? Supply is new material, precision control, nanotechnology, life sciences, manufacturing, convergence. Demand is clean energy, Six Sigma power, efficiency of consumption, ecological balance, more advanced living, and workspaces, global equity. So you see, every slide is equivalent to one complete lecture. But today, I'm just giving you a glimpse of, chemical engineering horizon. So the chemical engineer is a multidisciplinary engineer, a strategic problem solver. It takes clue from transport phenomena, from thermodynamics, from kinetics, from material science, from management economics, from biology, genetics, from computer science, and then application field is design engineering, plant operation, process optimization, engineering of living system, energy engineering, material research, environmental engineering, biotech, safety engineering, and nano engineering. So new horizons are, frontiers areas are alternative energy. Please be careful. This is the future of chemical engineering. alternative energy, nano manufacturing, novel materials, and alternative energy is ecology friendly, sustainable and safe energy for all. Nano manufacturing, taking a bottom-up approach to manufacturing mechanism at nanoscale to yield product of high quality with zero wastage. Novel material, efficiency of usage of material, safe memory alloys, new fibers. This is the future. Beyond current framework of plant design and engineering, we should think of seriously, we should be serious of developing biocatalysis, genetic reforestation, waste recycling. This is the newer era. So biocatalysis means microorganisms and enzymes to catalyze and reactions such as polymerization without any harmful effect. Genetic reforestation is production of healthier and fast-growing trees using principle of genetics and biotechnology. We have to use optimum use and do the recycling to use the waste material. So last 5,000 years was economics of linear mechanics. Chemical engineers were doing only extraction, exploitation, and experimentation. But the future possibilities are economics of closed loop harmony. Until unless we will not move towards this closed loop harmony, we cannot save our Mother Earth. So, agro, energy and power, and knowledge of recovery and recycle. There should be a closed loop where biomass, clean water, clean energy has to be come into the loop. And we have to create such technologies which can create this kind of technology which is in harmony with the nature. So chemical engineering, education, and industry had to rekindle the spirit of inquiry. Means, again, renewability and intensity versus conservation intensity. These are the two vectors. Within that, we have to configure the current process. And we have to inquire a lot. What are the possibilities? What are the pros and cons? How we should move in which direction? So the journey forward is towards a new integrated vision for intelligent, holistic, mass and energy balance. It is not in the seeming, it is in the being, but even more in the becoming. Let wish for the best. This means that's not, we cannot solve the problem only by thinking or by, preparing ourselves. We have to start action, only then we can solve the problem. Now I'll discuss few more slides, which are the current situation in India and our personal efforts to solve the problem. Means personal effort means effort of my group, my students. You just see, I suppose that is visible to everybody. If I ask what exactly it is. In a common lecture, people say there is a heap of paper, heap of bed sheets. But what is this? This is a heap of hides, buffalo skin. You know that Kanpur, Chennai, and Calcutta are the biggest center for leather processing in India. And the smallest unit of this are processing around 60 to 65 hides, that is buffalo skin, per day. So we are, slaughtering so many chemicals, so many animals every day to get leather product. And what is happening? In processing of this leather product, we're creating a lot of pollution. And if a single drop of water emits out of any industry or any commercial complex or any residential complex, that moves to the rivers and degrade the river. In Ganga Basin, where we live and where 40% of Indian population is living, a single drop emitted from any source is entering into the Ganga and killing the river. And that's why we have killed majority of river of country. And situation is similar everywhere. You move from north to south, you move from east to west. Situation is similar. And we are interested only in physical good. So we use many leather products, and we are not processing only our leather products, but we are importing leather from other industries like Europe, Denmark, Italy, and processing here. It seems that our air and water is very cheap. and we are polluting our rivers. And that process later goes back to Europe and they stamp their mark and that again come to the Indian market. It is sign of slavery, like East India Company. So we should certainly define a policy whether that is required for country or not. This is big industry. You see, I keep moving. I do monitor all these activities. This is a city like Delhi. You see, and a BG residential colony on the roof, people are processing this week. Tirupati is one center where a lot of, hair is produced, and this hair is being processed in different industries to make wig. And that is very much required for those ladies who feels that in every party they should have different add-on. And in turn, when these hairs are being processed, lot many hazardous chemicals, hydrogen peroxide, sulfuric acid, that is being used and that is being drained into the community and municipal drains. And you can understand how damaging it is. You cannot even stay there. This is my photograph standing on that particular industry. You see how much chemical vapor was being emitted there. This is pre-corona era. This is not the corona era. Everybody has used the mask only to avoid the hazardous toxic chemicals. So we are simply destroying our land, our air, our water. This is the situation of Yamuna in Delhi. You can visualize how much waste material we are creating through refractory organics, and mostly is being done by the chemical engineers. So this is the time to ponder over, to think over, and chart the new path. So I say that this is the kachra economy. And people say that Gai Hamari Mata hai. I'm talking in Hindi, sorry. I suppose you can understand a bit. And I generally say, Gai Hamari Mata hai, humko kuch nahi aata. You don't know anything. We are fighting for cows, and majority of cows are dying eating plastics on Indian streets. And that is the situation everywhere. This is a very interesting story told by Professor Raghunath Anant Maselkar Sahib, one of the finest chemical engineer of India. And what he told, that if you see two ponds in a village in summer season, what you will find, one has gone dry, but another is still full of water. You please try to understand what exactly the reason behind that. What he says, that the pond which is having good flora and fauna is a home for dragonflies. And these dragonflies secrete a fine polymeric layer on the river water, on the pond's water, thereby creating additional resistance to the mass transfer, thereby reducing the evaporation rate. And you can save the water from evaporation losses. So now you can very well understand that if we go in synchrony with the nature, we try to learn with the nature, we can create lot many product and we can save lot many natural resources. And that is the demand of today's world. So our chemical engineers can help our farmers by designing simple, cheaper solar dryers, because majority of our farmers are not getting return of their produce as they are perishable. And nowadays, people are asking for solar dried tomato, solar dried mushrooms, solar dried, grapes, fruits. So if chemical engineer can take it as a entrepreneurial venture, create cheaper solar dryer, supply to the farmers individually or through the cooperative, they can help the farmer economy, agriculture economy, and create newer product, valuable product. One more example, India is producing around 40 million metric tons of, rice husk. Earlier, nobody was thinking this particular thing as a resource. But only 10-15 years back, when few people have started using for gasification, and one of our students, Gyanendra Pandey, has started gasification of rice husk as in Bihar, to create electricity and its distribution, it has given a lot of money to the farmers. Now everybody is purchasing the rice husk at the rate of 4 to 5 rupees per kg. So additional value of the West to the farmers. And this is the process. You see, paddy from the field goes to the rice mill, where rice is taken out and rice husk is stored. We send to the husk power system plant, that is gasification plant. We create electricity out of that. It can be used in houses, for irrigation, even for running the mill. The leftover rice husk ash can be blended into the cement, and you can also earn the carbon credit. This was a good business. People have started doing that. This is the biomass utilization, second generation. But we have gone again one step ahead by use of this rice husk ash in the manufacturing of precipitated silica, which is the raw material for glass manufacturing industry. So generally, glass manufacturing industry creates silica out of silica sand. This is the high temperature, high pressure process. That is extensive use of energy. So if you go for search of, benign processes, we have created this silica out of rice husk ash. We designed the reactor and manufactured. You see that black ash has been converted to this sparkling white silica. And for that, Lockheed Martin Award 2015 has been given to Bridge Company, which has been tutored by 3 chemical engineering students of mine, Tanmay Pandya, Nikhar Jain, and Abhishek Poddar. So now this company is working in Rajasthan, Punjab, Haryana, these 3-4 companies, and they are creating wealth out of the West. Again, Naveen Kumar, one of my students, has started working on reverse osmosis. RO plant is creating 2-3 problems. Lot of wastage of water, lot of consumption of energy, and mineral depletion. So we started working on those direction, and we have improved upon wastage of water. Earlier, out of 1 liter, 750 ml was being wasted. Now we have created a situation where only 300 ml is being wasted. We have reduced the energy consumption by half, and we are still working to improve upon, the material mineral content, because as you know, there is a limitation of membrane technology. If you go for higher selection, losses will be higher. So we are still working on that. One of my MTech student, Dinesh Mantri, has created this Beji Pure. In the era of Corona, everybody was apprehensive of eating even vegetable and fruits. So how to wash that? So he has created this vegetable and fruit washing sachet. So you see, there are n number of opportunity for the chemical engineers, especially those who are innovative and who do understand the need of the society, and we are well aware of the life sciences also. This is the era where I keep upon asking the students, requesting the students, so please try to learn the trick of life sciences. That you give you a lot of newer horizon for the development of product. And in your case, that is the ideal situation where chemical engineering and biotechnology is working in one department. That is the best possible combination in any place. So one of my students have even created detergent out of the Rita, one of the, forest produce, and has empowered lot many tribal women. So that is the need of the society today. And finally, I will sum up by saying this: Prarambhete na khalu vigna bhayena niche, prarambhe vigna vihita viramanti madhya, vigna hi punah punah pratihanyamana, prarambhe chottamajana na pratijanti. Be patient and tough. Someday, this pain will be useful to you. कुछ लोग होते हैं, there are few guys who do not start with the fear of failure. There are few guys who are better than earlier one. They do start, but they leave the work in between in fear of, onslaught of failure, you can say, onslaught of problems. But those students will be winner, will keep upon investing their time and energy for the goal they have set for themselves. And India needs that kind of chemical engineers. We do have good knowledge of chemical engineering, that is unit processes and unit operation, in addition to knowledge of management economics and life sciences, and a bit of exposure to entrepreneurship. That is the recipe of success as I visualize. So I wish you all a bright and successful future in your chosen field. And remember, when you get out of the institute, work hard and have fun. Thank you. Thanks a lot.
Thank you, Dr. Mishra, for your lecture. It was highly insightful. I just at this time would ask the participants to, if you have any questions for Professor Mishra or even the faculty members and the students, you're kindly welcome to ask them now.
Yeah, Professor, this is Rangavashyam here, faculty. I'm also working on this environmental research. The question is with respect to the sustainability, like how about the sustainability if you are exploring in terms of the natural based material? So that's what the challenge always there associated with these applications.
So if I'm right, you are asking what exactly the possibility of sustainability, because that was always there, and we are still talking, and we are not moving ahead in a significant way in that particular direction.
Yeah, if it is in case of microalgae, that's towards the biofuel productions. Okay, in terms of cultivation practice and to scale up those constraints. So that's what still we are hindering with that.
Yeah, that is still there, I suppose. But microalgae, what I suppose, that can be used not only for fuel, that can be used for materials also. So if I are going to design a complete refinery where there is product, materials in addition to energy, then that will be, I hope, a sustainable product manufacturing company. But still, lot many research is needed in that particular direction, and still people are working. But I hope that in near future, because few companies are now coming up in the US and Europe, so within next 10 years, I suppose the technology will be matured enough to create, refinery based on natural algae in India. That is my assumption.
Yeah. Okay. Thank you.
Good evening, sir. This is Gautam Jagdishan here. Just had a kind of a question which one of the students had raised earlier. So, what we have actually seen either from the leather industry or the dyeing industry or any other process plant, much of those industries do not, or at least earlier, did not focus on environmental regulations and treatment and so on, because the new age solutions are slightly costly and they do not want to incur the cost. So, for example, let's say we are talking about the textile. I mean, I'm sorry, the leather industry, where the contaminants are usually chromium and acidic effluent and other heavy metals. So the question there is what can, much of these industries are small business industries. So what can small industries do in terms of finding sustainable solutions to treat all of this contamination?
Thank you, Gautam sir. So I've been associated with the monitoring of effluent treatment plant of majority of industries at the Ganga Basin from last 3-4 years. And with the sustained effort of Pollution Control Board, what we have seen that people have started thinking about the now sustainability and environmental pollution. And now every industry is having at least, pre-treatment facility, you can say. So smaller industries should go for only pre-treatment, where they can do the settling, they can remove the sludge, they can do some coagulation kind of practices, and later on that can be sent to the common treatment facility created by industrial cluster. And then again, very stringent monitoring is needed, because even community effluent treatment plants or common effluent treatment plants are not even being working properly, and they are doing many bypasses. So pollution control board authorities has to be honest, and we Indians should certainly try to understand that ultimately these natural resources means a lot for humankind. And earlier it was practiced, why dilution has been practiced in chemical industry? Because earlier, contamination sources were limited, and, natural resources were in, many quantities. But what is happening now, this, disposal, reckless disposal is simply killing our rivers. So this is the high time to minimize our, profit margin, to go for the newer technologies which consume less. There are not proper even chemical management system in these industries. By proper monitoring or managing chemicals being used, they can reduce the stress on water. They will be using lesser water, thereby creating lesser effluent. So both the adoption of newer technology, chemical management system, and certainly love for the nature, all three combined, plus monitoring from Central Pollution Control Board, that will fetch the result. And I am hopeful in last 3-4 years, I have seen at least 30 to 40% improvement in this direction. And the fourth thing is that we should not, export leather from other countries to treat in our country. That is very bad.
Sir, continuing to that question was, we have recently studied reports where, both the Ganga and the Yamuna were actually cleaned up during the pandemic, the lockdown. So when we had that first lockdown for about 2 months, you could actually see blue waters in the Yamuna and the Ganga. So because you are from around that place, you are from Varanasi, have you actually seen changes after we started the phased, opening of our economy and so on? And how is the situation right now?
Yes, sir. So I was the first person who has reported this change in Ganga during lockdown. And that has been covered mostly by all the national news channels, and even from, European and Western, US channels. But I'm sorry that again situation is taking bad shape, and industry is not the sole reason behind that. Municipal corporations are the major violator of the norms. And what is the problem? That this municipal corporation, being the government authorities, the CPCB could not take the stringent action on that, these authorities. And the major cities which are lies on the bank of Ganga or Yamuna, they are creating many sewage water. So if we are not treating these waste, we cannot save rivers. So situation is again going bad in Yamuna as well as Ganga.
Okay, thank you, sir. Thank you.
Thanks a lot, sir.
Sir, you have Siddhant Singh who has a question, and he says, we use mineral oils about 70 to 80% in almond oil companies. So how can we actually replace that or make the product better? Because mineral oils are also considered to be carcinogenic.
So Siddhant, sorry, I will answer this question after some time. I'll send you exact solution for that. Answering instantly will not solve your problem. I'll certainly, if you write down your email ID, or I'll, my email ID is with the organizers. You please send your query and I'll come up with the answer within a day or two.
So what we can do is we will take a note of this question, and Rangabhashyam sir or Naren sir can send you an email, and you can respond to that, sir. Thank you, sir.
Yes,
sure. Thanks, sir.
Another student by the name Kalevanan, he has a question. He says, can you provide some insight into the hydrogen economy?
So many attempt is being made on creation of hydrogen, and there are a number of technology, right from using light to biomass sources, different sources are there. Creation of hydrogen is not a problem. There is no technical hitch in creating hydrogen from different sources and different technology. Now the problem is storage of the hydrogen, and still we have to work a lot to reach a situation where hydrogen fuel will be economic fuel to be used. That is my answer.
Okay, thank you, sir. Any other questions by the participants? Okay.
Good evening, sir. My name is Kalaivanan. I'm from fourth year chemical engineering department, Sastra University.
Please.
Sir, I wanted to ask you a question, sir. Right now, the trends have been like said that every country, every developed country and developing country has been progressing like exponentially in the hydrogen economy, sir. So India has not even started a step. So that's why I wanted to ask your point, sir. Have we started it?
If you talk about the government of India's policy of Niti Aayog, you say recently they have started giving a thrust to methanol task force, ethanol task force. Still, they have not created task for hydrogen energy. So we are lagging behind, not only in the policy point of view, but still we are lagging behind in the creation of technology, as I have already told you, in hydrogen storage. So
yes,
there should be a push from government end. As they are pushing methanol economy or ethanol economy, if they will come out with hydrogen economy thrust for that, will certainly move in a positive direction, I suppose.
Yes, sir. Thank you, sir.
Okay. Thank you very much, sir. So now I would ask Naren sir to speak a few words.
Yeah. So good evening, Professor Mishra. It was really delightful to have you as part of the sixth lecture series. In fact, I should first say that the last lecture for this semester has been like, it has given a complete closure of a vision of chemical engineering. Right from the beginning, you started like what is the need for chemical engineering, its perspective with respect to the population, the needs, the requirements, how the company, how the industries progress, and the livelihood progress is related to economy, taking examples from your own lab in terms of leather industry, cosmetic industry, I mean, which you touched upon in terms of the wig, the artificial hair processing. And also, you also touched upon an example of how to get silica from rice husk, which is not only in terms of knowledge. I would rather say that to the students who are listening to us, it throws open an opportunity to create knowledge into a wealth asset for the country, right? Because silica processing is not only it's in terms of energy intensive, but high pure silica is actually an extremely beneficial economic asset for the country if we want to go in for an semiconductor based revolution, given we have this all IoT and all following up. So that's the message I would like the students to take, that it's not only the chemical engineering is a knowledge-based industry, but it serves as an ample opportunity where you can convert that knowledge, if you have an entrepreneurial spirit, to something as economic asset, as a wealth asset for the nation, keeping intact both the environment and ecology on par and making it equitable to all the stakeholders. And personally, I like the Johari window representation of the conservation and sustenance that you have put as two vectors. Thank you, sir, for spending your valuable time with us, taking through about, I think it is like 300 years of chemical engineering history packed in just 60 minutes. Thanks a lot for your patient answering of questions of the students. I take this opportunity to thank all my department colleagues, the Dean, Dr. Rajan, Associate Dean, Dr. Ponuswamy, the organizer of the event, Dr. Rangabhashya, and my faculty peers, Dr. Aragesan, Dr. Gautam, Dr. Saravanan, and Dr. Shankar Jha, and the students who have come. And I am sure that all of us are benefited. And I think your lecture today marks a successful one spectrum of the lecture series at Shastra. And we are geared up to begin this lecture series again as we go to the next semester. Thank you, sir. Thanks a lot. Yeah.
So one addition to that, I
Yes.
do speak on 4 fields. One is chemical engineering,
Okay.
energy, environment, entrepreneurship, and personality. So
Right.
these 5 are my domain. So we
Yeah.
can meet again whenever required. So how
Right.
people can understand their own virtues, how their personalities, how they can become a successful entrepreneur, how can they be catalyst to change. All are my domain. So we can next time, anytime we can discuss. Thank you for inviting me. It's a
Right.
good experience interacting with you guys, and it's always welcome to collaborate, to meet newer people and newer groups. Thanks a lot.
Right. Yes. When I think the normalcy resumes through Dr. Rangabasham, I would definitely invite you and would seek your presence at our institutes so that you can also see our facilities. And I think that will open up a lot of collaborative activities, especially in terms of the bioenergy environment systems. Thank you, sir.
Thanks a lot. Goodbye. Thank you.
Yeah.
Good day.
Bye.
Thank you.
Yeah,
Professor.
thank you.
Thank you.